Hi everyone, I'm Chris Strutman, and I want to welcome you to our first ever Master Lab. This is FPE 1001. This is going to be the first of a three-part series. I'm Chris. We'll talk about me in a second, but the goal here is to get everybody familiar with format-preserving encryption. So we'll talk throughout the three parts of the series. We'll talk about we'll do a little bit about me today, an introduction to FPE as a technology, and when to use FPE, maybe benefits, impacts, other solutions as well. There's a lot of different things out there. FPE is one possible tool. It's a great tool, but we want to talk about it in depth a little bit. Part two, we're going to get very practical, encrypting and decrypting data with FPE, how you can operate over the data while it's still encrypted. So maybe you don't need to decrypt every single row of data or every single value in every single object to figure out how you're going to use this data. And then also maybe we're probably going to talk about key management as well. And then the last one, we're going to talk about impact, both functional impact. So how does this look for the tools in your ecosystem, ETL tools, things like that? The impact to the data user, scalability, reliability, elasticity, cost, all of those things. And then we'll also talk about business impact. Almost every need for encryption in the industry is driven by some kind of regulatory or compliance framework. And so we'll talk about how you can use FPE to satisfy those. Those will be in part 2 and 3 today. We're just going to handle some introductory material. First, a little bit about me. I'm Chris Strutman. I'm the co-founder of Alter. I'm also the CTO. I oversee product engineering, field engineering. So if you're a prospect or a customer with us, chances are you've talked to one of my field engineers, IT, support, and compliance. You get a pretty well-rounded idea of everything that goes on in our industry. I also get to talk to customers a lot, which is extra awesome. Helps me understand really what people are trying to do, especially when it comes to warehousing data and protecting data when it's in the warehouse. So without further ado, we'll jump right into it. The introduction to format preserving encryption. And the first thing I want to say is just a kind of a quick note. This master lab is to discuss FPE as a technology. FPE is it's a broad statement. There's lots of different implementations of FPE. Alter happens to standardize on the FF31 implementation. There's a lot of different parts of the Alter product. You can marry this data protection with policy and things like that. We're not going to talk about that in this series. We'll do that in other series and other collateral that we generate. The purpose of this whole entire series is to talk about FPE as a standalone technology and also maybe a little bit of just broader encryption. So we'll say, what is format preserving encryption? Well, NIST says it's a cryptographic technique that encrypts data while preserving its original format and length. I personally, I look to extend that a little bit. You can cryptographically secure data with hashing or anything else. The big thing that you get with encryption, especially format preserving encryption, is not only do you get to preserve the format and the length, you also get to get the plain text back under the right circumstances if you want the plain text back. This is just kind of a crude example of format preserving encryption. You can see here we have what looks like a social security number. It's just a bunch of random numbers that I picked. You've got 3 digits, a hyphen, 2 digits, a hyphen, and 4 digits. On the other side of FPE, once the data has been encrypted, you have 3 digits, 2 digits, and 3 digits delineated by hyphens. Same with an email address. You have the prefix, the domain, and the top level domain delineated by an at and a period. Prefix, at, domain, period, top level domain. Format was preserved all the way across. You can do the same thing with something even a little bit more complex, like an address. You have a number, a letter, a period, and then some words. And then on the other side of the format preserving encryption, you have a number, a letter, a period, and some words. All right, so next we're going to cover when to and when not to use format preserving encryption. So wanted to go through some of our best customers. They understand the impacts of the technology that they're using. I have on one of the later slides. If all of the data is a nail, FPE is not a hammer. It's not a single-use technology that solves all of your problems. It's great technology, but there are some places where you can't use it. So do use FPE to encrypt the text of data in known format. If the format of the data is known and the format of the data is valuable to keep around, great use for FPE. It may be valuable for a consumer of data to know that a specific data element is maybe an email address or a phone number or a social security number. And maybe you want to know that without accessing the data itself, without accessing the email address. FPE is a great use case for that. Also, it might be a great use case for downstream or even upstream actors in the data ecosystem. So maybe you have a data quality tool that's checking to make sure the data meets a certain format, or your ETL tool is going to encrypt the data and drop it into a data warehouse or something like that. FPE is a great use case for that. Also, legacy systems that require on formats of data to be the formats of the data to be present in order to operate. Maybe it's some old system that's been freeze wrapped or whatever. FPE is a great use case for that. Do not use FPE for low entropy values. Proper FPE implementations necessitate a minimum and maximum domain size. It's all done on the size of the alphabet that you used. We can get into that in subsequent sections. But for now, the important thing to understand is when you encrypt something with FPE, there has to be a minimum and a maximum size. If the value is low entropy, for example, so a relatively low entropy value, for example, is state, right? There's only 50 of them, and typically they're delineated by 2 letters. FPE, I would argue, actually, any encryption or any data protection is not particularly valuable in that case, even though your regulatory or compliance framework might dictate that you do something with that data. Basic dictionary attacks are going to be able to get around that very quickly. It doesn't matter how you protect the data. Low entropy values are not great for format preserving encryption. By what do I mean? Just so everybody's clear, by low entropy value, what I mean is you've got a set of very bounded set of possible cipher plain text, and it's very predictable. And oftentimes, when you have those very small sets of possible plain text, they follow an even distribution, right? So it's very predictable output, very predictable input. Do use FPE when the size is a similar thing, when the size is known and bounded. Again, there's a minimum and maximum length. On the opposite side of low entropy, when you've got things that are very, very large, FPE is not particularly performant in those cases. There are workarounds for these minimum and maximum sizes. Their NIST kind of frowns upon them. You do accept either a little bit of security risk or you accept some performance gains. They're not great. I would argue it's probably good to look at a different data protection method if you're looking at either very small values or very large values. So I've seen customers try to shove entire XML documents through format preserving encryption. There's a couple things that's wrong with that. Number one, the performance, very, very low. Just by the nature of how FPE works under the hood, you're not going to be particularly happy with the performance of that. But more importantly, functionally, it's just not the right tool. On the ciphertext side of the FPE, when you're encrypting an XML document or something like that, same with something like a JSON object or anything, you're going to get the FP part of format preserving encryption. You're going to get the format preserving. So what you'll be left with is a ciphertext. It's still got the open carets. It's still got some text at the beginning of the tag. It still has all the equal signs. It still has all the quotes. It's not going to be what you really, really want. And it's not going to be useful really in any capacity. You can't take an XML document parser and parse that and then get any kind of usable output out of it. You can't parse that down into some kind of subdocument and then decrypt that. That won't work either. This is just use cases where FPE is just not a good fit. Again, I put on the slide here, if FPE is a hammer, not all of the data is a nail. One last thing to consider, always consider where the data is going after the encryption. If it's going back to rest, there's going to be encryption operations to get the plain text back. So if you're encrypting billions of records per day, just know that data is going to be encrypted, and somehow, some way, you might want to get that plain text back. So you always just want to factor that into your architecture decisions when you're using format preserving encryption. Very great, very fast tool. In sections 2 and 3, you're going to see how quickly you can encrypt data, encrypt a lot of data, keep its structure really, really quickly. obviously keep the format and still operate over the data. So we're trying to minimize the times you need to do those mass decryptions of data, but sometimes it does happen. If the data is going into a data warehouse for some kind of data mastering use case where you need to do broad searches over the data, you need to contemplate that on in when you do the encryption operations and when you do the decryption operations. What data elements do you do encryption over? What data elements do you choose to leave in plain text? So the database can do a really good job of optimizing its queries and ultimately doing a good job of being a database. So that's kind of the key material for part one here. I did want to take a moment to discuss what's coming up in parts 2 and 3. We're going to be encrypting and decrypting data with FPE. I'm going to sit here and I'm going to walk you guys through it. The demo environment is being built right now. We're going to talk about key management, what it looks like for multi-tenant environments where you've got maybe a lot of different customers' data in one place and you need to um, encrypt the data differently depending on that tenant or that customer. Key life cycles, key rotations, things like that. Those are all things. Doesn't matter what type of encryption you're using, you always have to contemplate the key and its life cycle and where it lives. We used to say security is only as good as where you keep the encryption. If you keep the key to your house under the doormat, eventually your house is going to get broken into. Also, we're going to talk about how to operate over the data while it's encrypted. We're going to leverage a property called determinism to maximize the performance impact of queries over, to minimize the performance impact, maximize performance of the queries over the encrypted data. We'll do some real world examples of FPE inside of a data warehouse like Snowflake. And then, like I said, lastly, we're going to talk about impact. There's a lot of things to consider when you choose to adopt a data protection technology, both non-functional impacts, business impacts, and functional impacts as well. So the last thing for this section, I set up an email address, fpe1001@alter.com. I'd love to hear you guys' questions, anything that you want to have covered in kind of subsequent sections of the Master Lab. Again, it's fpe1001@alter.com. I'll take the questions, I'll put them up on the screen, and we can talk about them kind of as we're doing them. But I really hope you look forward to and you join sections 2 and 3. Thank you.